Hey guys, today I'm going to be explaining the process of nuclear fission. So in nuclear physics, the process of nuclear fission is either a nuclear reaction or a radioactive decay process in which the nucleus of an atom splits into smaller parts. This process often produces free neutrons and photons and releases a very large amount of energy. For some background on it, nuclear fission was first discovered in 1938 by German Otto Hahn and his assistant. The process was named analogous to binary fission of living cells that also split into two. It is an exothermic reaction which can release large amounts of energy, both as electromagnetic radiation and as kinetic energy. In order for fission to produce energy though, the total binding energy of the resulting elements must be greater than that of the starting element. And finally, fission fragments are not the same as the original atom, and the two nuclei produced are comparable, but they're clearly different sizes. Nuclear fission produces energy for nuclear power and drives the explosion of nuclear weapons. Both uses are possible because certain substances called nuclear fuels undergo fission when struck by fission neutrons and emit neutrons when they break apart. The most common nuclear fuels today are plutonium and uranium. Nuclear fissions in these fuels are the result of the nuclear energy produced when a nucleus captures a neutron. This energy resulting from the neutron capture is a result of the attractive nuclear force acting between the neutron and nucleus. The fission of a nucleus requires a total input energy of around 7 to 8 million electron volts to overcome the nuclear force that holds the nucleus in its spherical lobe shape. However, you need to know that the electromagnetic repulsion between the two fragments is what results in two fission fragments moving away from each other, and that results in a really high energy while releasing around 200 million electron volts as opposed to the 7 to 8 million volts that is used to overcome the nuclear force. A common application of this process today can be seen in nuclear weapons. This type of nuclear weapon is called a fission bomb, or most of you have probably heard it as an atomic bomb. It is a fission reactor designed to release as much energy as possible before the released energy. So in fission weapons, a mass of fissile material is assembled into a supercritical mass either by shooting one piece of that subcritical material into another, or by compressing using explosive blends of material using chemical explosives. However, the biggest challenge today in nuclear weapons, specifically nuclear weapon designs, is to ensure that a significant fraction of the fuels consumed before the weapon does not destroy itself. An example of a fission bomb, which I'm very positive most of y'all are familiar with, can be seen in World War II in 1945. The Manhattan Project of the US military during this time carried out most of the early scientific work on fission chain reactions that resulted in the production of the bombs that destroyed Hiroshima and Nagasaki. The fission bomb that blew up Hiroshima was called Little Boy and weighed around 4 tons and yielded an explosion equivalent to 15 kilotons of TNT. The one that blew up Nagasaki, however, was called Fat Man and did similar damage. All in all, after both of these bombs went off, around 200,000 civilians were dead or injured. Alright, now for some interesting facts about nuclear fission. Nuclear power plants use nuclear fission, which has the potential to be safer than nuclear fusion, but has not yet been developed to operate within a larger power plant. Nuclear energy comes from uranium, which is a non-renewable resource that must be mined. Every 18 to 24 months, a power plant must be shut down to remove its spent uranium fuel, which becomes radioactive waste. Nuclear power plants generate around 20% of US electricity. And finally, nuclear energy is used in more than 30 countries around the world and even powers Mars rovers. Thank you for letting me talk to y'all about the process of nuclear fission. I hope you learned something new. Thank you.